If you know the ternary search tree find algorithm, the ternary search tree insert algorithm is actually fairly simple. It's almost the same as the find algorithm, except during our traversal, if I ever need to traverse down a child that doesn't exist yet, I can just create it and continue as normal. And then the last word in my traversal will become a word node. So I'm going to show this by inserting the following 4 words into an empty ternary search tree. So for the first word, it's pretty easy. We just create a straight line down containing all the letters of this word. But really, I mean, it's what I describe here. My current letter is C. Let me use red for that. Current letter is C. My current node should be the root, but there is no root. So I can just create C as the root and make it my current node. So my current letter equals my current node, which means I need to move to the next letter in my word, and I need to traverse down my middle child, but there is no middle child. So I can just create one with the next letter. There we go. And now I can traverse down this new middle child I created. So my current letter equals my current node's letter. So I go to the next letter. I should traverse down, but there is no middle child. So again, I can just create a middle child with the next letter. Now I have my middle child. I can traverse down. Next letter is L. It's equal to my current node's letter. So I need to traverse down, but there is no down child. So I'm just going to create one with my next letter. Okay. Now I have a middle child, so I can traverse down it. Now my current letter equals my current node's letter, and my current letter is the last letter of the word. Therefore, I should make this a word node. So my current node becomes a word node. And I'm done. Okay, what about the next word? Me. I start at the root, and I start at the first letter. My current letter is greater than my current node's letter, so I need to traverse right. But no right child exists, so I can just create one with my current letter. Now I can traverse down that right node, down the right child. Okay, so now my current letter is equal to my current node's letter, and I'm not at the last letter of my word, so I need to traverse down. I'll just shift this over, and I need to traverse down. No such middle child exists, so I'll create one with the next letter of my word, which is E. Yay, now a middle child exists. I can traverse down. My current letter equals my current node's letter, and my current letter is the last letter of my word. Therefore, I'm done, and I need to make my last node of my traversal a word node. So I'm going to make it a word node. There we go. Now this word is inserted as well. Now for the word mind, I start at the root, start at the first letter. M is greater than C, so I traverse right. M equals M, so I go to the next letter and I traverse down. I is greater than E, so I need to traverse right, but no right child exists. So let me create one containing I, my current letter. So now I can traverse to the right child as I want it to do. I equals I. It's not the last letter in my word, so I need to traverse down. But I can't, so I'm going to create a new node containing the next letter of my word. And now I can traverse down. Okay. N equals N. So I go to the next letter, and I want to traverse down because it wasn't the last letter yet, but no such child existed. So I create it. And now I can traverse down like I wanted. My current letter D equals my current node that's letter D. It's the last letter in my it's the last letter in my word. Therefore, I'm done with that. Now make the last node that I ended at become a word node. Okay. Now mind is done as well. Last one, mid. Start at the first letter, start at the root. M is greater than C, so I traverse right. M equals M, so I go to the next letter and I traverse down. I is greater than E, so I traverse right. I equals I, so I go to the next letter and I traverse down. D is less than N, so I traverse left. Uh-oh, no left child exists. So I'll just create one with whatever my current letter is. There we go. And now I traverse as I wanted to do. Okay, D equals D. And this is the last letter of my word. So I'm done with my traversal. And the node I ended up at becomes a word node. Oops, I forgot to make that one the letter pink as well. So I made this a word node. Now my traversal is totally done. My last word has been inserted into this TST. If you know the ternary search tree find algorithm, the ternary search tree remove algorithm is extremely easy. You basically just do the find algorithm, and whatever node you end at, just make it not be a word node. If the find algorithm fails at all, you just do nothing. The word doesn't exist, so you don't have to do anything. Let's try it out. So here's an example ternary search tree, and I want to remove these 3 words from it. So first, the word me. So I do my find algorithm. I start at the root, start at the first letter. M is greater than C, so I traverse right. M equals M, so I go to the next letter and I traverse down. E equals E. It's the last letter of my word, so I'm done. My traversal is done. Let me just make the current node not be a word node anymore. And that's done. Easy as that. The word me is removed from this TST. Let's see what happens if I try to remove the word min. So I start at the root, start at the first letter. M is greater than C, so I traverse right. M equals M, so I go to the next letter and traverse down. I is greater than E, so I traverse right. I equals I, so I go to the next letter and traverse down. N equals N, and it's the last letter of my word, so make whatever node I'm currently at not be a word node. Well, that's fine. It's not a word node. It's still not a word node. Yay, done. Okay, now the word can. I start at the root, start at the first letter. C equals C, so I go to the next letter. I go straight down. A equals A, so I go to the next letter. I go straight down. N is greater than L, so I traverse right. Uh-oh, there is no right child. Therefore, can doesn't exist in this TST, so I'm done. I don't have to do anything to remove it. So the TST remove algorithm is exactly the find algorithm. It's just that if you ever fail the find algorithm, as I did in both of these scenarios, you just don't do anything. If the find algorithm succeeded, as was with the case of me, just make the last node that you end at not be a word node anymore.